Math used an organ. The organ, one of the most complex and grand musical instruments, produces sound through mathematically tuned pipes, airflow control, and acoustics. Mathematics governs every aspect of its design, ensuring precision in pitch, resonance, and harmony. Let's explore the role of math in organs. Organs use math in pipe length and frequency. The pitch of each organ pipe is determined by its length and shape, following the fundamental frequency equation. F equals V to L, where F is frequency, V is the speed of sound, and L is pipe length. Longer pipes produce deeper tones, while shorter pipes create higher pitches. Harmonics and overtones. Organ pipes are tuned to specific harmonics, ensuring a full and rich sound. Mathematical ratios help in designing pipes that resonate with perfect overtones. Airflow and pressure calculations. The amount of air pushed through the pipes determines loudness and timbre. Precise pressure calculations ensure that each note sounds clear and balanced across different registers. Keyboard and octave scaling. The organ's keyboard follows the 12-tone equal temperament system, where each key is spaced logarithmically to maintain consistent pitch relationships across octaves. Mathematical principles applied. Wave equations determine sound frequencies in different pipe lengths. Logarithmic scale ensures accurate tuning across multiple octaves. Fluid dynamics governs airflow and pressure within the pipes. Mathematics plays an essential role in designing and tuning the organ, allowing it to produce majestic sounds that have captivated listeners for centuries.